This is part 2 of lesson 3, VPN fundamentals. First we'll discuss edge routers. They transport virtual private network over public networks. They ensure that all network traffic complies with the firewall. They're ideal for customer and suppliers or business partner access, and best suited for controlled access into a demilitarized zone. The corporate firewall passes LAN to LAN traffic. Joined networks are treated as any other LAN route. Users don't have to re-authenticate across segments, and no additional firewall filtering or restriction applies. VPN appliances are dedicated network offload devices. They are specialized to handle VPN offloading from routers and host systems. They can be placed outside corporate firewalls for traffic filtering and supplements existing corporate firewalls that do not support VPN services. VPN architectures. Remote access host to site supports single connections into the local area network. They support private local area network access without edge routers, corporate firewalls, or appliances. LAN to LAN and WAN, site to site, supports LAN to LAN by way of the internet. Combines site to site with remote access VPN capabilities, scales to large groups of users in network endpoints. And client server host to host supports direct connections by way of the internet. They provide additional security over shared public infrastructure and links mobile platforms to mission critical systems and services. A corporation may control different aspects of the network. The provider network uses a service provider infrastructure for VPN services. The customer network, the customer controlled network infrastructure for VPN. Customer site, physical location is the only control point, and a provider device not under customer control operates as a routing device. Authentication, authorization, and accounting, AAA server deployment. This tracks who you are, authentication, checks what you've been authorized to do, authorization, and records what you've done, accounting. Different technologies are for different technological needs. Desktop and server software for remote client connections, dedicated firewalls, optimized routers, VPN servers and VPN concentrators, network access servers, or NASs, for service providers, and VPN network and policy management centers. Here we see a VPN used to connect multiple local area networks. The VPN link going to a firewall and then to a level 2 switch connecting various different devices on each side of the internet. Here we see a VPN used to connect a local area network with remote mobile users. Here we see the home or corporate entity on the right, connected by a level 2 switch, passing through a firewall. The VPN link goes into the internet, and then from there a VPN link to each one of the remote users. One is a desktop and one is a laptop. Here we see a VPN used to connect multiple local area networks with remote mobile users. And again, you see the mobile users in the middle connecting on the VPN link across the internet, and then a firewall protecting each of the local area networks connected by a switch or a router on either side of the internet. VPN encryption modes. Tunnel mode protects the packet from the header to the payload, whereas transport mode protects only the packet payload. Endpoints can terminate a host computer system, edge router, corporate firewall, or dedicated VPN appliance. They provide secure remote access, site-to-site connectivity, and they operate in 2 modes. The tunnel mode, which we see here, protecting the entire packet, and the transport mode protects only the packet payload. The VPN tunnel. It encapsulates an entire packet within another packet. It encrypts the payload and header, IP, Internet Protocol, and UDP TCP to protect the identities. The carrier protocol used to transmit the VPN packets. Encapsulating protocol packages the original data. The passenger protocol, the original data payload or protocol being carried, encapsulates packets that are not routable through the Internet, routes non-routable address traffic over public infrastructure, and is ideal for gateway-to-gateway or network-to-network communication. VPN transport encapsulates only the packet payload, cannot prevent some forms of observation such as eavesdropping and alteration, does not conceal endpoint identity, is ideal for direct endpoint-to-endpoint or endpoint-to-gateway communication. Cryptographic protocols ensure the confidentiality and non-repudiation, require encryption algorithms, protocols, and authentication methods. Endpoints must support identical cryptographic protocols and methods on each side. Otherwise, you would not be able to encrypt the data and ensure that it could be decrypted on the other side of the tunnel. Here we have the first of 3 slides describing how we establish a VPN connection with cryptography. Bob and Alice, and Bob trying, of course, to send the message to Alice. So let's go through this step by step. In step 1, Bob computes a hash from a message. So you can see the hash here in step 1, and we get some result. Notice that we have the private key here, Bob's public key, Alice's public key, and Alice's private key. So we're in step 1. In step 2, Bob is going to encode the hash using his private key to create a digital signature. In step 3, Bob generates a random key K1. In step 4, Bob uses K1 to encrypt the message. Now in step 5, Bob is going to obtain Alice's public key, and in step 6, Bob is going to encode K1 with Alice's public key to create a digital envelope. And then in step 7, as you can see the little envelope symbol here, now it's been locked. It's a digitally secure envelope. Bob sends the digital signature, the encrypted message, and the digital envelope over to Alice. So let's see what Alice does. In step 8, Alice is going to use her private key, because remember, Bob obtained her public key, which was created by her private key, so she's going to use her private key to decode the digital envelope to reveal KQ. In step 9, she uses K1 to decrypt the message. In step 10, she computes the hash of the message and obtains the result. Then, in step 11, she gets Bob's public key, and in step 12, applies that public key by using Bob's public key to decode the digital signature to obtain Bob's hash value. Now she's going to compare the 2 hash values, and if they are identical, then the message has its integrity and has not been tampered with or changed from when Bob sent it to her. Here, this exchange on the previous 2 slides enables a symmetric key to secure subsequent messages from Bob to Alice or from Alice to Bob. Once a VPN has been established between Bob and Alice, an exchange key, session key K1 exists at both endpoints. Using this shared session key, Bob can encrypt messages envelope 1 to send to Alice, and Alice can encrypt messages envelope 2 to send back to Bob. So once they have digitally, once they have secured both ends, that session key exists, and they can use that for further messaging. VPN authentication, authorization, and accountability mechanisms allow approved external entities to interconnect and interact with private network. They use varying methods for authenticating users, passkeys, biometrics, and they track and log user interactions to maintain user accountability. VPN supporting services and protocols. Enterprise-class VPNs require enterprise-class security that support confidentiality, strong cryptographic tunneling protocols which avoid intercepts and sniffing, authentication, strong authentication for non-repudiation and identity spoofing, and secure cryptographic transport protocols. Authentication established levels of authorization and access using passwords, two-factor authentication, biometrics, and other forms. Cryptographic transport protocols don't play well together. Internet Protocol Security IPsec VPNs use IP version 4 and L2TP running over an IPsec layer, whereas transport layer security TLS SSL tunnels over IP version 4 networks on the Internet. Platform-specific transport methods are using proprietary protocol formats. So in conclusion, strategies for protection of remote network access using a virtual private network. We discussed the network architecture necessary for a VPN implementation, the types of VPN solutions and common protocols used for connectivity, and planning and selection of VPN options for the best value to the organization. You've used Wireshark before, you can use it again along with a tool called NetWitness Investigator in the virtual lab for this. In using Wireshark and NetWitness Investigator to analyze wireless traffic, you'll use Wireshark to view and analyze an existing capture file. You'll see some of the wireless aspects of networks as well as some of the aspects of the network traffic that remain the same regardless of the physical transport, be it wired or wireless. You will also explore NetWitness Investigator, a threat analysis application which gives you a different view of captured network data, making deeper analysis much easier. This concludes Chapter 3.